Well, it started streaming with 2 minutes to go until I said people should show up, so we'll see what happens here. Attendance was pretty good for the last one of these, so let's keep our fingers crossed that people will show up for this one too. Well, look at that. We have 2 people here. Curious to know who they are. Hello, Donald. And who's our second person? I guess our second person's going to be a mystery person. Okay, Donald. Well, since you're the first to arrive, if you have questions you want to queue up for me, or any specific thing that you want to talk about for this review, I guess you have my undivided attention at this point. All right, review set 9C number 6. Huh. Okay, I'm just going to screenshot that and pop it into the OneNote file. Okay. Soil contractor Frank was given the following dimensions over the telephone. The triangular garden plot ABC has angle CAB measuring 44 degrees. Side length AC is 8 meters long and BC is 6 meters long. Soil to a depth of 10 centimeters is required. Explain why Frank needs extra information from his client. Well, I suspect you already know the answer to that because you are referencing that this is an ambiguous case question, and it is. The issue here is that you could actually construct 2 triangles based on this information. So, in order for it to really be a question where ambiguous case comes into play, you basically can't have a diagram. That's sort of your first clue. If no diagram is given, then I start to become suspicious that maybe it's an ambiguous case question. The reason why it's ambiguous is because if I start to actually draw this out, and so I have vertex A here, and I'll have, let's see, A, C, and then this is B. The reality of the situation is I know that this is 8 meters long. I know that this angle is 44 degrees. And I know that the side length BC is 6 meters, but that 6 meters could go this way, or it could technically cut this way and still fit. So it becomes tricky. This is why it's saying Frank needs extra information from his client. He cannot be sure, based on the description that was provided over the phone, that the triangle is the acute triangle, or it could be the obtuse triangle. That's actually A, B star, and C. And so it becomes a little confusing that way. Not necessarily impossible, but certainly you cannot be confident which triangle we're actually speaking about. It's why with an ambiguous case question, you're basically taught to solve for both, unless there's more information that's provided saying, okay, you only have to find the obtuse triangle or the acute triangle. So that's why Frank needs more information here. He can't be sure which of these two triangles he's actually making into a garden. So then after we've acknowledged that, we can move on to part B, which says, what is the maximum volume of soil needed if his client is unable to supply the necessary information? So one of these triangles is obviously bigger than the other. I'm pretty sure everyone looking at this would agree that the acute triangle is a larger size than the obtuse. And so basically what we're going to need to do is figure out the measurements for the acute triangle. We're going to need the area for that triangle, and then we're going to need to just multiply that by a depth of 10 centimeters to get the volume. Okay, so let's work towards that. So let's see here. We have angle A, and we have the side length A, are the ones that are opposite each other. So 6 meters there, 44 degrees there. And we have the side length that's opposite B, which is 8 meters. So what we need to do, if I look at what information is given right now, I'm missing 2 angles and I'm missing 1 side length. Now, anytime you have a pair of side and angle, that's a good indicator that you should be using sine law. Never mind the fact that this was an ambiguous case question. If you ever write out the information you have from a triangle and you look at where things match up, if you have a matching pair, then it's usually a good indicator you're going to use sine law. If you have a mismatch of sort of one thing of A, one thing of B, one thing of C, it's usually a better indicator that cosine law is going to come into play. So seeing that I have those A's matched up, I'm going to use my formula for sine law. So sine of angle A over side length A is equal to sine of angle B over side length B. And so if I start to plug things in here, we get sine of 44 degrees over 6 will be equal to sine of B over 8. And so I can rearrange this just to get sine B by itself. Sine B is equal to 8 sine 44 over 6. And so now to actually find angle B, I'm going to have to do sine inverse of that quantity. So we'll do sine inverse of 8 sine 44 over 6. And I'm going to have to get out my calculator. And I got to make sure my calculator is in degrees, which is important. If you've reset your calculator, remember it defaults to radians. So as soon as you go to start calculating things, you may end up with a very different answer if you leave your calculator in radians. So we'll do sine inverse of that value. And when I do that, I'm getting 67.85 degrees. And so that has filled in a little bit of information that I didn't know before. I'm just going to write that in a different color. 67.85 degrees. With that information, I can start to find other pieces of information within the triangle. Once you know 2 angles, you kind of know 3. So angle C, by my calculations here, is 68.15. And that's helpful to me because that angle is between the 2 sides that I already knew. And that's going to help me calculate the area of a triangle. So my first step here was to find the angles. My second step is now to do the area. I have to do 1/2 AB sine C. When we do area of a triangle using trig, we use 2 side lengths and the angle between them. That's why I needed this angle here. And so I'll do 1/2 times 8 times 6 sine of 68.15. And when I evaluate this, I'm going to get my area of that garden, which is 22 point, I'm just going to round to 3 significant figures here, 22.3, what were our units? Meters? Meters squared. Now that's not the end of the problem, because the question does ask, if I scroll back up here, what's the maximum volume of soil? And that's where that comment about 10 centimeters of depth comes into play. The idea is it's not just the area of the garden that's important. There's 10 centimeters of thickness there. And so if I picture this garden, I'm just going to redraw the picture here for a second. If I picture it like a triangular prism, right, it does have a little bit of thickness to it. Now the volume of a triangular prism is just the area of the base times the height or the depth. And so I've already found the area of the base is 22.3. So now I just have to multiply it by its thickness, which is 0.1 meters. Very important to put that in the right units, otherwise you're going to get an answer that is slightly askew. So you end up with 2.23 meters cubed. And that's your answer for that one. So that was the full solution for the question that Donald requested, which was number 6 from section 9C. So now I'm going to move on to Hannah's request. Now, Hannah, I think you joined after I'd already gotten started. I'm assuming at least. We went from 2 people watching to 3, and I'm assuming that you were the third. So just as an update for anyone who has joined recently, I don't know if people have left and come back, but the stream's on a little bit of a delay. That's just the nature of the way it works. So I'm saying things, and then about 30 seconds later is when you're seeing them. So when you say something in the chat, just know that I don't necessarily respond to it right away. I tried to do that last time, but it just became this really loopy thing of people were typing stuff to me. I was responding 30 seconds later. They were immediately typing a response, and I'd already moved on to something else. So I'm having people put their requests in, and then I'll go through the question. If you do have a question at any point, though, through an explanation, please make sure you just chime in. Because if you don't say anything in the chat, I'm really not going to know that something wasn't clear or you wanted me to re-explain something. And that's how we're going to kind of run things here. So Hannah requested, oh darn, I toggled away from the chat before actually reviewing what question that was. 9A, number 3B. All right, let's take a look at that one. 9A, 3B. And I'm just doing a screenshot here. If you ever notice the screen goes dark on the stream, don't worry about that. Ever since Windows pushed out a new update, when you do a screenshot, it, for some reason, decides to black out all the light. And we end up, yeah, looking like things are going weird. Oh, okay. I see Donald has asked another question. So how do you know if it's ambiguous? So, okay, I'm going to address that just before I move on to Hannah's. Sorry, Hannah. I'm bumping your question just a little bit. In general, what you need to observe to know that something is an ambiguous situation, you have to be given that angle side pairing like we had before. So you'll have this angle here, so you'll know this, and you will know this side length, and you'll know this side length. So let's, I don't know in the note with Miss Van Huel what letters you guys use to refer to them, so I'm just going to throw in, um, A's and B's or something like that. So we'll say that this is B and this is A, which would make this angle B. Basically, what you have to know is that this value of B is smaller than A. That's usually a good indicator that it's going to be ambiguous, because what it means is that if I was to take this line and rotate it around, it's going to actually fit in and make another triangle with that extended line of the angle. See the dotted line that I put in? That side B is going to be able to be repositioned to make a second triangle while still keeping that angle the same. So that's usually a pretty good indicator, is if the B value is smaller than the A value. If that side length was longer, like if this side went way out to here, then if you picture rotating that line around, when you rotate it around, it's going to end up way over there. It won't actually be able to complete a triangle with that angle. Normally, if I was doing this in person with people, I would actually get some physical objects. I'd go and raid the design lab and get some straws or some old wooden dowels or something. If you actually take, let's say you have drinking straws at home or toothpicks or something, draw an angle on a piece of paper and then take two of those straws to be side A and side B. Make sure that side A is longer than side B, and you can actually see how when you rotate it around, you could conceivably make two triangles. That's probably one of the easiest way to get a hands-on appreciation of why this exists. I suppose another way of looking at it, I could pop open GeoGebra and do a little model of it. Actually, I wonder if I already have one created. I'm just going to take a look for that. Oh, it looks like I may have one already prepped and ready to go. How convenient. So I'm going to open up GeoGebra here. Aha. Okay. Now, I'm not entirely sure how easy it is to see this right now. If that's abundantly clear. I don't know, you guys would have to tell me. But if you look at the length of this line, this one is designed so that it's actually longer than this side. So I've got an angle of 30 degrees right here. I'm just trying to see on stream if you can actually see the cursor. Yes, you can. So I've got an angle of 30 degrees right here. This side length here of the triangle is of length, oh gosh, I think it's length 10. And so this side being bigger, when I rotate it around, you can see I can't actually connect with that 30-degree angle while keeping this side as long as it is and still making a second triangle. The only way it makes a triangle is way out here. Whereas if I had, let's say, this, where is it? If I had this line instead, this can only make a right angled triangle because the side opposite the angle is way too short. And so in this instance, I actually can't move that side anywhere and still make a triangle. The only place it hits that 30-degree angle, the bottom part of that 30-degree angle, is if it's perfectly straight up and down and makes the height of the triangle, which makes it also a right angle triangle. The ambiguous spot in between comes from a situation like this, with one of these guys. And I gotta switch to a different circle too. Not that one. There we go. Because here, the side that's labeled J, it can connect with that 30-degree angle over here, but if I rotate it around, and you can see the movement of the rotation based on this circle, if I rotate it around, it hits that same 30-degree angle over here as well. And so that's how you could end up with the obtuse triangle if you assemble the sides together that way, or the acute triangle if you assemble them the other way. And so that's when you have an ambiguous situation. Basically, the way you would need to calculate it is if you know that side length opposite the angle is smaller than the side touching the angle, that's key. But that side length opposite the angle, it also has to be bigger than the height of the triangle, which you can find by doing a sine theta, right? That would be the height of that triangle. So as long as that side length b falls in between those two values, then you're going to know it's ambiguous. But more often than not, like if I'm being sincere here, more often than not, your biggest indicator will be that there is no diagram given. If there's no diagram given, that's a huge red flag that it's an ambiguous case question. So I know that's kind of a long-winded answer to your question, Donald. But those are sort of two different ways that you can look at it. There's sort of the concrete way of just playing around with the measurements and seeing it doesn't fit. There's also the algebraic way of actually checking it for yourself. If that value opposite the angle falls in between the length of the side touching the angle and the height of the triangle, then you know it's an ambiguous case question. Okay, we have someone in here who's new but is not there as their name. I don't know who you're tearing me apart Lisa is, but welcome. I'm going to move on to Hannah's question now. So Hannah's question was from review set 9A, and it was number 3B. And she says, I got 5, and I know the triangle's ambiguous, but I can't find the other value. Okay. So let's take a look at this. This question's actually very different from most questions that you see when you're studying trig. I kind of like it for that reason. But it's a little different. It's a little out there. I was working on this question with a few people in class, and I was noticing people struggle with it then, for the same reason I expect many of you would be struggling with it now. And the issue is that that side that's opposite the angle, you're told to use cosine. And normally what happens in that situation is you have information like this. You know this side, you know this side, you know that angle, and you're looking for that side. But that's not what we have here. We have an angle, and we know the side opposite, which would suggest you would go about using sine law here. They asked you to use cosine law to find x. And so a lot of people would be tempted to say, oh, okay, x squared is equal to 7 squared plus... I feel like a lot of people almost do that on autopilot. Some of you probably started this question, you got right into writing all this out, and then you got here. And you were like, wait a minute, what's the angle across from x? I don't know it. It is a mystery. And it's because that's not actually how you're supposed to set up this question. I don't know this angle, and I can't actually solve for it very easily to set this up the way you would traditionally. What you need to do is not go down that route, the old familiar route. The way you need to set it up is recognize cosine law always works with angles and sides that are across from each other. So the angle that I'm given, I'm going to start here at this end, the angle that I'm given is cosine of 60. That's what I'm going to end up working with here. The side that it's opposite is that side that's length 7. So I'm going to put that on the other side of cosine law and fill in the rest accordingly. So these other two sides should be 8 and x. And so I'll fill in these things. And that's what my cosine law is going to look like for this question. So I noticed Donald has said in the chat he did a quadratic, or used a quadratic with this question. And he's absolutely right. That's what this works out to be as you start simplifying. 7 squared is 49. 8 squared is 64. We end up with minus 16x cosine 60. And so when you do cosine 60 on your calculator, you should end up with 1/2, provided you're in degrees. If you end up with something different, then that would be why. So if I have 1/2 times 16, I'm just going to have 8 there. And so it simplifies to be a nice quadratic. If I move that 49 over to the other side, I'm going to end up with 0 is equal to x squared minus 8x. And if I do 64 minus 49, I get plus 15. This quadratic should be fairly familiar to us. It's actually one that I use quite a lot in a bunch of questions. I don't know if you guys even realize how many times this quadratic has come up again and again and again. But it's a nice, easy one to factor. Two numbers that multiply to be 15 and add to be -8 would be -5 and -3. And so when this factors, I get x minus 3 times x minus 5. And so those are my two values for that missing side. Now, Hannah says she got 5. And so I suspect that the way you solve for that, the way you get 5 as your only answer and don't get to the value of 3 would be if you just use sine law to get to the answer. So if you didn't say use cosine rule to get the answer, and you just ignored that instruction and you just said, forget you, textbook, I'm going to do what I want. And you set it up this way. You said sine 60 over 7 is equal to sine, I don't know, I guess not x, sine y over 8, right? We could go about solving for that missing angle that's across from the 8 centimeter side, because we'd end up with this. I would do sine inverse to get the angle, and I would get something that I'm plugging into my calculator. Wait for it. I would get that y is equal to 81.8 approximately. And so when you use that to get the angle, you find that that angle across from 8, I'm just going to label it back up here in the diagram, you get that this is 81.8 degrees. And so if you just subtract all of those from 180, what do I get here? I get that that top angle is 38.2. And so the tricky thing there is that you're operating on the assumption that it's acute, and when you did sine law, you didn't account for a potential ambiguous case scenario. Now, here's the thing. The question actually does provide a diagram. So to Hannah and anybody else doing this question, I would argue that this one's actually not ambiguous. You might be inclined to think it's ambiguous because you got two answers. But let's not forget that Katie, in this question, was asked to draw the triangle exactly. She drew a picture. She made the assumption that it's acute. I don't know if she's drawing that from seeing somebody else do it. Actually, I guess that's not clear, is it? But if that triangle was given, so if I gave you that picture on a test, you know it's acute. Although I will say don't trust a diagram. If a triangle looks like it's an acute triangle, it's probably safe to assume it's acute. I would never assume something that looks like 90 degrees is 90 degrees, but it's very rare for me to ever give you a diagram and it's an acute triangle and then it turns out that one of the angles was actually 160. That's not going to happen. So in this situation, if that picture was given, you could actually assume that it was only 5 as an answer, because that would be the acute triangle, which is what the picture suggests. However, if you did use sine law, as we did here, then you have to consider the ambiguous case. If no diagram is given, then this becomes a necessity. You would have to consider the angle that's supplementary with 81.8, which is what, like 98.2? And so the other y, I usually call it like a y prime or a y star. I don't want it to be too dissimilar, but I do want it to make it clear that there is a separate angle. 98.2 would be the angle if this was in fact a triangle that looked a little bit more like this, where this was 8, this was 7, this was x, this is 60. So now this angle in here would be 98.2. And you could continue solving the question with that information. You're obviously going to get a different angle for z, right? Because now this angle at the top's a little bit skinnier. And then you would be able to use well, at that point, any information you want to go ahead and solve. So if I was to look, I'm just going to summarize the information I have here. I'll label that X, Y, Z. If I look at the acute triangle, the angle that I have is 60 here. This one's 81.8. This one's 38.2. And the side lengths that go with it okay, sorry, I've just realized that the side length on the diagram's labeled X. That was bad form on my part. This one's 7, this one's 8. And so the side length that's actually Z, based on how I labeled my vertices, is the X that we're solving for. That's a little messy. In the other triangle, though, I have this, and different angles for Y and Z. So X is 60, Y in this triangle was 98.2, and so Z I didn't actually solve for yet. Oh dear, my calculator's buttons, because I'm using the one on my phone, are not very responsive. This is why it's good to have a TI whatever at your disposal. Physical buttons never have mispresses. There we go. So I have two triangles with two different sets of information. And so if I was to do that, so Hannah said she used sine rule to get the angles and then use that to use cosine rule. We basically have that information now. If I was to use cosine, I would need these two sides and this angle. And in the other triangle, I would use those same two sides, but a different angle for Z. And so you can see here, it will still work. I'll say that x squared is equal to 7 squared plus 8 squared minus 2 times 7 times 8 times cosine of 38.2. This would have been the step that, Hannah, I suspect you actually worked through because you said you got the measurement of 5 on your first run. And so I'm pretty sure once I do this, I'm going to get something really close to 25. Yep, 24.9. And so that tells me that x is approximately 5. If I was to do it with the other triangle, it's basically the same calculation. I just need to change that angle to be slightly smaller. And so when I do that, I get what I'm hoping will be close to 9. Yep, I get 9.00958, etc. So when I square root that, I'm just going to get approximately 3. Now the tricky thing, I think as I zoom out and you take a look at it, you can see why one strategy is simpler than the other. Not to say that either one is wrong, but there's definitely one here where you're doing a little bit less work as you go through. So that is just important to keep in mind here. You could actually do an ambiguous case question using cosine law, and you'll just get 2 solutions from your quadratic. And perhaps, actually, given the number of people who have said that that's a concern for them, I mean, even now James is here, or maybe he was here all along and didn't say anything, I don't know. But James is here and he's saying, Mr. Grant, I still didn't really understand how to determine if there's ambiguous case help. I mean, honestly, you could solve any ambiguous case question using this as well, using cosine law, but having the x be on the right-hand side so you get a quadratic. Yeah, we might actually do another question like that just to show how that could make it simpler. I don't have a problem with you using sine law and just finding the 2 possibilities for the angle and going that route. It does seem like it is a little bit more complicated, though, a little bit more work. Hannah, I don't know if that helped to clarify things or not. I'm happy to go through another question if you're still unclear. And considering James is chiming in, also asking for more clarity, we may spend a little bit more time on ambiguous case in a little while. I noticed Donald queued up a whole slew of questions, and James has queued up one. Uh, and and so okay, so we're going to start to get through those. I don't know why so many of you are speaking different languages too in this stream. How many languages do you think I'm fluent in? I'm fluent in barely one. Um, James, to answer your question, so that means that when there's a positive quadratic, I'm not sure what you mean by positive quadratic. What I will say is, in any situation like that, where you could use sine law or you could use cosine law with a variable, in those situations, if you solve that quadratic, if there's two positive solutions, then you actually had ambiguous case. If one of those solutions ended up being negative, then guess what? You didn't have ambiguous case, and you could have just solved using sine law. I think I might actually do an example that illustrates that in a minute. And also, James, to your question, binomial expansion was not on the outline, and therefore it is not on the test. I really think James doesn't trust me. It's probably because I was going to prank him and print an alternate copy of the test just for him that was only binomial expansions, just to see how he would react. Anyway, no, the test is only on those 6 lessons of trig. So there were 4 that you did with Miss Van Hewell, and then we did arc length, sector area with me, and problem solving. That's it. And most of the stuff you did with Miss Van Hewell was review of last year. So I'm basically giving you a trig test that's half grade 10 review and half new stuff. And the new stuff is actually still really closely tied to grade 10. Anyway, I'm going to scroll back up. I need to see which questions Donald was asking about. I'm just going to screenshot all these questions. If you have another request, just pop it into the chat now, because I'm hopping over to the textbook to do some screenshotting. And then I will come back to the stream. So Donald said 8C. So I'm going to jump to a different part of the textbook. 8C number 5. Good question, good question. I need to figure out how to turn off those notifications it gives me every time I do a screenshot. He said 8C number 12. Oh, that's a very good one. And 9B number 4. Oh, but James requested one from 8B. 8B number 11. Why is it screenshotting them so small? I swear they're getting smaller each time. Okay. 228 is the page. We're into section 9B, number 4. Oh, yeah, there was a lot of debate about this last one that Donald requested, 9B, number 4. Who was I working with on that one? Sophia, Coco, and Max, I believe, were bickering somewhat about this one, and I agree the interpretation of it is a little loopy. I'm not even 100% sure my interpretation of it was correct when I was working with them. They seemed to feel that my approach made the most sense based on the language. But anyway, okay. So we'll do these few questions. We're now focusing a little bit on, actually I'm going to change the order of them because 3 of the 4 of them are related to arc length and sector area. And that last one's an application problem, so we'll circle back to that one in a minute. But this first one is a request from Donald. It's from 9A or 9B. Oh, sorry, 8C. Oh, man, I was way off. 8C. This one was from 8C. This one was from 8B. And this one was from 9B. Okay. Thank you, James, for stating your undying loyalty in the chat. Of course, that's what I'm looking for is your math teacher. All right, number 5. So we've got a tidy little diagram here. It says state the value of theta in degrees and in radians. So basically, to kind of calculate this, you kind of need to look at the information here that's given. This is an equilateral triangle. You can see the little tick marks say that all 3 sides are equal. So that means this is of length 1 as well. So I can basically solve backwards if I wanted to with cosine law and get that length. But, I mean, realistically doing that would be wildly inconvenient because, again, I said it's an equilateral triangle, which tells you directly exactly what theta is. In degrees, the angles in an equilateral triangle are equal to 60 degrees. All 3 of them would be the same. In radians, now you would just have to convert that, which means you have to remember to convert to radians, you just have to multiply by pi over 180. That conversion's not given in your formula book, so you really do need to make sure that you know that. So to convert it into radians, I will take 60 and I will do times pi over 180. So 60 times pi over 180 is going to simplify. If I divide by 60 on the top and bottom, 60 gets divided out completely on the top, and I end up with 3 on the bottom. So I have pi over 3 is the equivalent of 60 degrees when I'm talking about radians. Next, I am asked to state the arc length AP. Now, arc length is a formula that is provided in the formula booklet, so this one you don't have to worry about knowing. The conversion from degrees to radians and back, you do need to know. But arc length being theta times r, that's given to you directly, so you don't even have to sweat it. So we would have theta, which it's important to remember the angle has to be in radians. So we already have that. It's pi over 3, and the radius is 1. So that means the arc length is actually pi over 3 units, I suppose, if you want to include units there. And then it says state the area of the minor sector OAP. So they are asking for the area of this region here. And again, that formula is given. It's in your formula booklet, 1/2 theta r squared. And so I know my theta, I know my r. So it's 1/2 times pi over 3 and times the radius squared, which is mercifully easy on this one because the radius is 1. And so I end up with 1/2 times pi over 3, which is just pi over 6. So pi over 6 units squared would be your answer there. That's the area of the minor sector. All right, if there are any questions about that one, I'm happy to go back and address them. And then otherwise, I'm going to move on to the next question, which is a fair bit more complicated. I like how Donald requested 2 questions. One is a very simple and direct use of sector area, and the next one is like the toughest question I would give you about sector area. So it's interesting to jump from like a 1 to dial it straight up to 11, but that's what we're going to do. So I haven't seen anyone chime in the chat saying that they wanted clarification on that one, so let's move to this next one, which is a doozy of a question. Or at least it seems that way, doesn't it? Because I'm sure there are some of you who look at this and you see a Venn diagram and you're probably thinking, oh my gosh, what does this have to do with anything? Geometrically, a Venn diagram has a lot of trig in it, believe it or not. All of math is very intricately connected. So we have 3 circles. Their radius is r, and they're drawn as shown. The idea is that each center of a circle is on the circumference of the other 2. So the center of B is right here, and it happens to be where the circle centered at A and the circle centered at C pass through. And the same is true for all the other centers. The reason why that's helpful then is because I know that the distance from C to B is the length of the radius. And I know that from A to C is the length of the radius. And I know that from A to B is the length of the radius. And so what I actually have within this diagram, although for some reason my pen was a little uneven, I'm going to zoom in and draw this. What I have is actually an equilateral triangle here. If I can draw it so it looks even remotely equilateral. There we go. So it's kind of the spiritual successor of that last question, which also had an equilateral triangle, which also meant we knew that these angles were 60 degrees or pi over 3 radians. And so it's all very much based on the same ideas. Now they say prove that an expression for the area of the shaded region is r squared over 2 times pi minus root 3. So the thing to note here is, yes, I do have that triangle, but then I also have these regions around the triangle, which are segments. There's this segment, and this segment. Now those segments are all equal in size. And the way you can figure out the area of a segment, let me just draw a sector here for a second. This is a larger drawing of a sector just to help us visualize. Any sector can be split up into a triangle and the segment piece. And so what that means is if in this question I were to find an expression for the sector and subtract the area for the triangle, that would give me the area for the segment. And so that's how I'm going to proceed with solving here. I'm going to recognize that the area of the segment, there's two things I actually want to write out here just to give us some guidance. The area of the segment is equal to the area of the sector minus the area of the triangle. And so the area of the region I can see then is the area of the triangle plus 3 times the area of the segment, which is what I observed before. And that's really the most challenging part of this question, I think, because once you know how to visualize it and how to move forward with it, the rest of it is just algebra. And as long as you're comfortable with your algebra, you should be okay. So the area of the sector will come from that equation 1/2 theta r squared. And the area of the triangle comes from my equation 1/2 AB sine C. So we'll do 1/2. The two side lengths of the triangle are r and r, so A times B is just going to be r squared. And then I have sine of theta. Now I actually know what theta is. I'm not plugging it in yet, and I'm kind of doing that on purpose. We're going to get there in a second. So on this next step, I know that theta is equal to pi over 3, or 60 degrees. And so if I plug that in, it's going to make this not perfect, but a little bit nicer. Now, sine of pi over 3 would be the same as sine of 60 degrees. And so if I find sine of 60 degrees, my calculator is going to spit out a value that's a decimal. As a fraction, that value works out to be root 3 over 2. Some of your calculators might give you that accurately. I can't say for certain. And so here, if I simplify these terms now, I have ended up with this. Pi over 6 times r squared minus root 3 over 4 times r squared. And then you can see here what factors out nicely. I can pull out 1/2 r squared, and what's left behind is pi over 3, and then minus root 3 over 2, I guess. Did I factor that out correctly? Yeah. And so I can then say, all right, that's the area of the segment. So I'll take that up here, put that into the area of the region. Area of the triangle is again 1/2 r squared sine theta plus 3 times that thing that I had from the last part. And I can start to tidy this up a bit. It's important to note the 1/2 r squared can factor out of everything. It just leaves me with sine theta plus, I'll distribute in the 3 times pi over 3, just leaves me with pi, and 3 times that part is negative 3 root 3 over 2. And when I plug theta in again, I'm just doing sine of pi over 3 once more, which again is that value root 3 over 2. So I end up with this. And if I gather these terms together, because there's a root 3 over 2 minus 3 of them, when I simplify that, that's the same as having minus 2 root 3 over 2, and the 2 on top and bottom here will reduce. And so that's how I end up with, oh, whoops. That's how I end up with the answer that they have. Oh, they wrote it as r squared over 2, but it's the same thing. 1/2 r squared times pi minus root 3. Now, the tricky thing I suspect is because we haven't talked too much about radians and special angles yet, I think that many of you might have found it difficult to, oops, that was supposed to be the highlighter. Many of you might have found it difficult to do this part where you get the root 3 over 2. I think that that would have been the non-starter on this question, because some of you would have had that as a decimal, and it would have made it impossible for you to get the answer that the book wanted. And so this one actually, I think I can say with some degree of certainty, I'm not going to put one quite like this on the test, for that very reason, that you would need to know those exact numbers in order for you to prove something like this, and we're just not there yet. This question would definitely be fair game later, but I don't think that's fair to assume it would show up on the test. If I did give you anything like this, I would have you probably work with it in degrees, just because it would make it easier to work with, or I would allow decimal numbers or something like that. I'd have to give you the radius, basically, because then you could do it on your calculator and express the answer as a decimal, and then that would be it. Okay, so I'm going to pause for a second just in case there are any questions about that one. In case James wants to chime in and ask, so will that one be on the test, now that I've said it won't be? Going once, going twice. Yeah, hi, Ian, by the way. I didn't know you were here. So yeah, that was the part, not understanding how the pi over 2, it's pi over 3. But how the pi over 3 became root 3 over 2, that's because we haven't actually talked about special angles yet. And so this question I would normally assign as part of the review for this test, but we also would have already done special angles. And so students would have known that sine of pi over 3 was equivalent to root 3 over 2. You guys don't know that yet. That's why I'm saying don't expect a question quite like this to be on the test. The only way anything even looking like this would be on the test is if I gave you the radius, because if I told you that the radius was something like 2, then everything else you can do with your calculator. You guys would have evaluated it and done sine of 60 degrees instead. You would have got a really weird decimal, multiplied it all out. Everything would have been fine and dandy. But you guys would not have to do this exactly in this form. Oh, Ian's perfect must be very sincere because he has like 5 T's on there. All right, so I think we're ready to move on to James's question then, which is 8B, number 11. And that says, find the radius and area of a sector of perimeter 36 with an angle of 2 pi over 3. All right. So find the radius and area. Let's picture this sector for a second. And by picture, I mean draw a picture. There's the radius, and this is the arc length, right? So apparently the perimeter, which is the whole way around, that's 36, which means that r plus theta r has to be equal to 36. That's the perimeter. If I simplify this, I get 2r plus theta r is equal to 36 as an equation. Now, I know what theta is, but I mean, that's not going to make the answer immediately apparent. There's still a little bit of algebra to be done here. So I've just plugged in that the angle here is 2 pi over 3. I can factor out an r, but then I get 2 plus 2 pi over 3 in the brackets there. Now this is where you're just going to have to calculate what that is. Two pi divided by 3. And so I get 4.09 for that. So I'll take 36 and divide it by that number. Oh, whoops, should press divide first, otherwise that doesn't work out. And I get that r is approximately 8.79, roughly. And so then I'm asked for the area, which is a separate calculation. So the first part's finding the radius, second part's finding the area. I'm going to use my sector area equation, 1/2 times theta, which is 2 pi over 3, times the radius squared. Now, if you're a real stickler here, you could put in the radius very exactly and do 36 over 2 plus 2 pi over 3, and then square that. I mean, you could put that in your calculator. I'm not super worried about my answer being far off if I've rounded, so I'm just going to put in 8.79, whatever I still have it in my calculator, so I can just grab that number, square it directly, and not really have to worry about any loss of precision. And so if I take that number, square it, and multiply it by 0.5 and by 2 pi over 3, then I end up with 80.96. And did we have units here? Yes, we did. So that's centimeters squared on the area, and I should have put centimeters on the radius. And so, James, I don't know. You requested the question. You said you always have you always find it challenging to get that answer. I want to check if that answer is in fact correct. So I'm just looking up in my textbook. Where's that from? 8B, number 11. Let's jump to the answers here. Review set 8B, number 11. Radius approximately 8.79. Area approximately 81. Oh, because they rounded to 3 significant figures, which would be why. So they looked at this and they said, okay, those decimal places need to go. They used the 6 to round the 9 up, and that's how they end up with approximately 81. But yeah, that's the answer for that one. Hopefully that added a little bit more clarity there, James. You'll have to weigh in on whether that clicked. I'm curious to know where the difficulty was, though. So one thing that I always miss out on when it comes to doing something like this versus working with people in person is I find there is some benefit to actually being able to see where people got stuck. But if there are no questions about that one, then we can move on to the next. I'm also just trying to figure out who's still here, because at this point, who have I seen? So Michael's here now. And James. I've seen Ian, I've seen Donald, I've seen Hannah, and I've seen Tristan. So we've obviously had some people cycle in and out. You just need to know what you've done wrong. James, do you want to email me your solution so I can take a look at it? Because I can, if you show me where you were struggling, then I can I can help you out there. Hi, Tristan. Okay, so we're going to move on then. It's 2 o'clock. Okay. Well, we're getting some good review done here. This is question 9B. No, sorry, question 4 from review set 9B. And so in this question, we have a vertical tree growing on the side of a hill with gradient 10 degrees to the horizontal. From a point 50 meters downhill from the tree, the angle of elevation to the top of the tree is 18 degrees. Find the height of the tree. So this question, as I said earlier, posed a lot of debate in class. I had Coco, Sophia, and Max asking me about this one while they were doing the review. And I will admit it does seem to be really weird in the way it's explained. So as I go through it step by step, so they say a vertical tree. So here I am picturing, some sort of tree like that that's growing vertically, right? Which would mean straight up and down. It's growing out of the side of a hill. That hill has a 10-degree angle to the horizontal. My horizontal here doesn't look very horizontal, but let's see if we can fix that. There we go. All right. And so the hill has an incline of 10 degrees, but the tree's growing vertically out of that. And then we're told that from a point 50 meters downhill from the tree, so maybe someone's standing right here so that this distance is 50 meters, that when I look straight up to the top of the tree, that angle of elevation would be 18 degrees. So they're saying that that angle, at least this is my interpretation, is 18 degrees. Which, because we already know that this one here is 10 degrees, right, because that's the steepness of the hill, it means that within the triangle, this one here is 8 degrees. And then they say to find the height of the tree. And so I think that's the way that you're supposed to set up the question. That's my interpretation, at least. Now, admittedly, that could be wrong, because do we have enough information to actually solve here? I mean, the way that I'm looking at it, this would be 10 degrees, right? Because if that's horizontal, the incline of the hill is still 10 degrees. The tree is perfectly vertical, so that means the tree and the horizontal form a 90-degree angle. So I would operate on the assumption that this angle was 80 degrees to complement the 10 and make 90. If that angle is 80 degrees, it means this angle here is 100 degrees. And now I think I have enough information in the question to actually solve. This angle up here would be 72, so that within the triangle I have 180. Now I have all three angles and one of the side lengths, which would allow me to solve for the height of the tree using sine law. Sine 72 is opposite the 50, and the height of the tree is opposite the 8-degree angle. So I think the height of the tree is 50 times sine of 8 degrees over sine of 72 degrees. So I'm going to go ahead and check that calculation. 50 sine 8 divided by sine 72. And I get the height of the tree is 7.32 meters. So I'm just going to jump to the textbook and actually check that. And this was from 9B, number 4. 7.32 meters, yep. So that works out to be the answer. Honestly, this question, the math of it The actual calculations you need to do, I don't think is overly difficult. The really difficult part of this question is, without a doubt, the wording of the question. Because it's a vertical tree, like there's a lot of information in the question that's given in the description in words, but what just happened to OneNote there? That's given in words, but is not given numerically. And so it says, vertical tree, that's how you know that it's like perfectly vertical to the horizontal, so that's how you know there's a 90-degree angle that you need to work with. I don't know. The question always throws people for a loop every year without fail. There's this one, and then there's a question with, I think, Sam and Max are looking at the top of a tree, and it's the 3D one. This question and that one, without fail, are the ones that students struggle with the most, which I don't consider to be a bad thing. I think that those questions end up teaching you the most. And so I hope that you get the most out of them. Now, Michael has just put in a request for section 9B, number 6. So I'm just going to screenshot that one and pop it into OneNote. Gosh, those notifications are annoying. And why does it screenshot them so small? All right. So 9B, number 6. Peter, Sue, and Alex are sea kayaking, as one does, but hopefully not in this season. Peter is 430 meters from Sue on a bearing of 113 degrees. Alex is on a bearing of 210 degrees and is 310 meters from Sue. Find the distance and bearing of Peter from Alex. Yes, the word problems and the parsing of the language strikes again. Okay, so we've got these three people. We have Peter, we have Sue, and we have Alex. We are told Peter is 430 meters from Sue on a bearing of 113 degrees. So if Sue is here, and this is directly north, in order for Sue to see Peter, she actually has to look at a bearing of 113 degrees. So Peter is actually, contrary to where I drew him, he's over here. Let's move Peter. And the distance is 430 meters between them. Alex is on a bearing of 210 degrees from Sue, and she's 310 meters away. So again, if Sue was sitting in her boat and she rotated 210 degrees, she would be looking directly at where Alex is. So this is 180 here, so 210 is somewhere this way. Now Alex is a little bit closer. She's only 310 meters away. So now that I've kind of visualized that, I'm going to draw on the line a little bit more solid. And there's point A, that's Alex. And this angle all the way around here was 210 degrees. And so if I connect A and P, that didn't work. There we go. I have a triangle here, and I want that distance between Peter and Alex. And it says the bearing of Peter from Alex. So basically, if Alex was looking north, what's the bearing she has to rotate to be facing Peter? So that's the information that I'm solving for. So I'm looking for distance, and I'm looking for a bearing. Now, based on the information that I have here, it's 210 degrees for Sue to rotate and see Alex. It's 113 degrees for her to rotate and see Peter. The difference between the two is what this angle is. So if I do 210 minus 113, I end up with 97. So this angle enclosed within the triangle is 97 degrees. That's basically if Sue was looking at Peter and then continued to rotate to Alex, that's how many degrees she has to rotate through. And so I know the two sides on either side here, and I know the angle in between, so I can use cosine law here. I see Tristan's chiming in with one of the hard-hitting questions. Why is Alex spelled like that? Tristan, I think the honest answer is because textbook manufacturers always find the most obscure spellings of names to use in questions. It happens all the time. I'm sure if somewhere in the textbook there's a Tristan, it's probably spelled like this, maybe. I don't know. It's just the way textbooks work. I'm surprised that's the first time you would have made that observation. Now back to these sea kayakers. I know the two distances on either side of the angle, and so that's going to help me find this distance. Using cosine law, x squared is equal to 310 squared plus 430 squared minus 2 times 310 times 430 times cosine of 97. So if I evaluate that, yeah, I don't know why Donald's speaking in a different language. Actually, I'm just going to find x directly on my calculator. I don't want to write out x squared. It's like a 6-digit number with a messy decimal. So if I just plug that into my calculator and square root the result, I end up with 559.9021048, and I'm sure that's not everything. That's just where my calculator cuts off. If I round to 3 significant figures, it's basically 560 meters between Peter and Alex. And so now that I know that, I can go and solve for the bearing here. Now the bearing might be a little bit tricky because remember, it's this angle here, rotating from directly north to the line connecting Alex and Peter. That angle's made up of two pieces. There's this piece, I'll just label that theta, which is within the triangle. That's easy enough to solve for. This piece, which I will label beta, which is outside the triangle, I can solve for that easily too, but you might not see how immediately. The bearing from Sue to Alex was 210. That tells me that this angle out here is 150. Because that's what completes the 360 degrees of the circle. What that means is because beta and that angle of 150 are supplementary, it means that beta is 30 degrees. So that one I can just figure out using angle properties. I didn't even really use any trig there. To figure out theta, though, I will need to use sine law. So my first step was this. My second step is here. Actually, I guess arguably my second step was that quick one. My third step is sine law. And I know that sine of theta over 430 is equal to sine of, I mean, I could use 97, I guess, over 560. So sine theta is equal to 430 times sine 97 over 560. Theta is equal to, and again, got to crack out the old calculator. Hopefully you guys are checking these as I go, because if I make a mistake calculating, I won't necessarily know. And I would absolutely ask you guys to give me the answers if we weren't on that silly delay. I'm getting that the angle is 49.65265.872, which is a god-awful mess, but when you round it to 3 significant figures, it becomes 49.7. And so the angle that I'm looking for, the bearing, this will be my fourth step. Why are all these pens so small? Every time I write, I feel like it's practically invisible. My fourth step is to know that the bearing that Alex has to rotate through to see Peter is the angle beta plus theta. And so that would be 30 degrees plus 49.7, which is why I suspect the answer, if you look it up, is 79.7. I seem to recall the most common mistake on a question like this is that people only solve for the angle inside the triangle, not recognizing that this is not a bearing measured from true north. And so you end up, getting an answer that's close. I would probably only take off 1 mark for that mistake. But Yeah, it does throw things off a little bit. Thank you, Michael, for verifying that 49.7 was indeed correct. Thanks, Donald and Tristan, for weighing in on something terribly irrelevant. But no, if you recall, I have a 2-week-old baby, so I have spent precious little time playing the new hit online shooter. All right, so I've gone through the queue of questions. I don't think I've left any questions unanswered for people who had them queued up in the chat. So if there's no other requests, what I think I'm going to do is go over a different way of looking at ambiguous case. And I'm not going to do this to try and mess anybody out. I'm going to do this because I want to show you another way of looking at those kinds of questions. And it's all based on the question that Hannah asked ages ago. I'm not sure if Hannah's still here with us or if she asked her question and then went back to studying. But I did want to kind of look at ambiguous case from a different perspective. So I'm just going to pick some numbers here that I think will do the job. So let's say that you have a 30-degree angle here. And this side length I'm going to make 10 meters, 10 centimeters. It doesn't really matter. And what do I want the side opposite it to be? I guess, okay. When I'm making an ambiguous case question, I've already said how you can check whether it's ambiguous case. Basically, whatever distance I give you for this side, it has, let's call this B. This has to be less than 10, because if it's bigger than 10, that side won't be able to make two triangles. But I know that it also has to be greater than the height of the triangle. Now, the height of the triangle I can find by doing 10 sine 30. And I pick these numbers very particularly because sine of 30 degrees is 1/2. So 10 sine 30 happens to be 5. So as long as this value that I pick for B is between 5 and 10, this is going to become an ambiguous case question. And so I'm going to just say that B is 6. Why not? There's 6 people watching right now. Let's just go ahead and say that this side length is 6. And so the idea here is that this could make two triangles. Now, the one way that I taught you to solve for them, solve for the missing side lengths, mind you, is to basically assume that there's two triangles and you can go ahead and use sine law to work through that. So let's actually label these with some vertices now. I'm going to say that this is A, and this is B, and this is C. So I now have two distinct triangles. There's triangle ABC, which is an acute triangle, and it looks like this, where this is 10, this is 30, and this is 6. But there is an alternate triangle, ABC. I'm just going to put some stars in there this time. Oh, I guess B is in the same place. It's only C that's going to be in a different position. And this triangle looks like this. We've got 30 degrees, A, B, and C star, which is in a different spot. And so when I go to solve these triangles, I can basically lay out what I have here. My angles A, B, and C, and my side lengths A, B, and C. And it becomes pretty clear that what I would be using will be sine law. That was how we were taught it. That's how you went over it with Ms. Van Huel. I've already done it once that way in this stream, in the question that Hannah asked about at the top of, not even the top of the hour. It's halfway past, or no, 2:15. So I don't know how long ago it was. And I think my brain is starting to get unraveled here. But anyway, earlier on in the stream, I wish I could tell you a time code, but we did a question that Hannah requested that worked out to be ambiguous case. And I showed how to basically break it down this way. Consider the two separate triangles. Consider the information that you know that's fixed. So side length A is 6, side length C is 10. That's true no matter which triangle you're looking at. The differences come up when you start to solve for basically angle C. Because you either have angle C, which is the acute angle you get, or you have C star. So if I go to use sine law here, and I set it up, I end up with something that looks like this. So sine C is equal to 10. Sine 30 is 0.5, so I'm just going to pop that in. And so this is going to allow me to solve for the angle C. Sine inverse of 5 over 6. That gives me the angle is, when it's acute, 56.4 degrees, approximately. Now, that angle for C is only true in this triangle. In the other triangle, it's the supplementary angle with that one. So if I do 180 minus that answer, I get an angle of 123.6 approximately. So I would do 180 minus 56.4 to get that angle. And then once I have those two different variations, I can start to solve for the rest of the values. So let's say I wanted that distance of B, the side length here, which is different than this one. I would be able to do that using, well, really any method of my choosing at this point. I can solve for the missing angle of B here by doing 180 minus 30 minus 56.4. And that gives me here 93.6. Another pen I've got to make a little bit bigger. And then in the other triangle, I do 180 minus 30 minus 123.6. And I get that that angle is actually 26.4 in this one. So this angle up here is 26.4. In this one, it is 93.6. So you can see how this builds out two different triangles. And then once I have this information, I can solve for the side length of B using sine law. B over sine 93.6 is equal to, and I'm just going to take 6 over sine 30 because I know sine 30 works out nicely. B is equal to 6 sine 93.6 over sine of 30, which is 0.5. So 6 sine 93.6. Oh, I typed in 96.6 by accident. And the tricky thing with trig is if you mistype things, you might get an answer that's really close, but still potentially incorrect. So I get 11.976, which is ultimately going to round to 12 for that side. And if I go and do the same operation with the obtuse triangle, that angle is not 93.6 this time, it's 26.4. But otherwise my strategy works out the same. 6 sine 26.4 over sine 30. That's going to work out to be what? 5.34 if I round to 3 significant figures. So those are the two answers that I get by using sine law the whole way through. Now the question that came up when Hannah posed it is if we're looking at that triangle and we just know this information roughly, and I was asked to solve for this side, could I not use cosine law to do that? Would it not be possible, I mean, if I have a calculator anyway, would it not be possible to set this up and say, since cosine law is c squared equals a squared plus b squared minus 2ab cosine of c, couldn't I take this pair here and just plug them in as those pieces of information that are opposite each other? and then just sub in the rest. Donald made the remark last time. That gets us a quadratic that we have to work with. Now, the question that was assigned from the review, that quadratic actually worked out pretty nicely. You will notice this one does not. Because cosine of 30 works out to be like 0.86. It's something not great. 0.866025438, because it's basically root 3 over 2. It's a number that we saw earlier. You guys don't necessarily understand the significance of it yet. It's much nicer when it's not a decimal. But if I did take that decimal and multiply it by 20, I'm going to get that coefficient is 17.32050808. Now, couldn't I solve this quadratic and get both of those answers? Well, let's take a look. This quadratic, I know, doesn't factor nicely. If you're not sure why, again, just please look at the coefficient on x. It's not going to factor nicely. But if I'm sitting here with a calculator, as I would be on a trig test, there's nothing to stop me from, say, graphing that. I could go into my calculator, graph the quadratic, and find the x-intercepts. And those would give me my two answers for the side length. So I'm just plopping that into the y equals menu. We're going to graph it. Of course, my scale is not well suited for this. So I can only see one of the answers. I'm going to do zoom fit. I really got to get my calculator emulator back on this computer. I should be showing you this. Oh, even zoom fit didn't work out very well. Okay, I'm going to change x min to 0, x max to 20. And I'm going to make y min -1 and y max 5. And we'll graph it again. There's one, and there's the other. And so now if I were to actually do second function and find the zeros here, if I can track my cursor at all, there we go. When I find the x-intercepts here, I get that one of them is 5.34 and the other one is, I'm willing to bet, close to 12. Let's see here. Yep, 11.97, so approximately 12 again. So you could actually set it up that way too. There's lots of different ways with trig to solve for these things. Sine law and cosine law are so closely connected that you can actually go either way in some questions. Even though last year you were probably very explicitly taught, if you see this, do this, and don't try to do anything else, there technically is some degree of flexibility there. And so I don't know if Hannah's still here and watching, but it was an interesting observation that with ambiguous case you could go either way. Now for people who are always worried about, well, what if it's not ambiguous case? If you solve it the quadratic way, one of those solutions is going to be negative if it's not an ambiguous case question. You will get one positive answer, which is the only answer, and then the negative answer is obviously not the length of a side. You can't have negative meters. And so you would just reject that one. And you only end up having one triangle in the end, which is okay. Because it means you remove the ambiguity of ambiguous case. You now know there was only one. Here, you see that there are two potential side lengths that would work. And so that is exactly what we would solve for if we broke it down and did it with ambiguous case. So that's how that all breaks down there. It's one way of looking at ambiguous case. I don't know if you guys want to see another example. I really do feel like ambiguous case works best. Like your understanding will grow the most if you actually work on it. I could sit here and do 20 ambiguous case examples, and some of you will watch and feel really confident, and then at the end of the day, we'll probably still struggle to reproduce those solutions. Anyway, The chat hasn't been terribly active, so I'm hoping that this was helpful. Haven't seen anyone weigh in with any new requests. Tristan was gloating because he was right that I hadn't played Apex Legends. James said he couldn't find. Have you been looking for that solution this whole time, James? That is just madness. Huh. I just realized as I right-click on users in the chat, I can put users in a timeout. That's interesting. I could also assign someone as a moderator of the chat. That seems dicey. All right, so do we have any other requests? What would you say is the thing students struggle with most that is on our test? Honestly, Michael, probably the word problems. I think we've kind of already seen a little bit of that because a number of people were struggling with that vertical tree one and a variety of other things. And so, oh, what's going on here? What the? Somehow the chat window ended up on my main screen. Thanks, Google. Anyway, yeah, so definitely the word problems. They are the biggest thing. Tristan and Michael would be good moderators. Yeah, not going to happen. And I don't know about Donald being a moderator, considering all the things he's been posting here that are in a different language. Hopefully people are posting things appropriate in a different language, because I can very easily copy and paste those and translate them. You're accepting of multicultural students. You were typing in Vietnamese. Do we have a Vietnamese student? One of the things Donald said apparently translates to "you betray, you pay the price of rice." Good grief. Can we do one more ambiguous of my choice? Sure, I can very easily make an ambiguous case question. Maybe there is a Vietnamese student watching. You're right, Donald. Who am I to assume that we don't have one in our midst? Here, I'm gonna actually. I've got an old ambiguous case question that I really liked kicking around somewhere. It's like an old trig assignment or something. I'm gonna see if I can find that one. If I can even remember where it would be. I've probably archived it years ago. Trig. Where is... I shall tell you this, if there's one thing that new IB curriculum is going to help me do, it's going to help incentivize clearing out my my Google Drive, which is just packed with stuff. Let's see. Ooh, this is really old. All right, so this is a question that I gave on a test ages ago. Get out of here, you notifications. Love how Windows assumes I take a screenshot and then would be surprised to know that I took a screenshot. Okay. So this is a question I gave on an old test a long time ago. I think this was back in 2013 or something. So what grade were you guys in then? It was a while back. Anyway, so if you're wondering why it's yellow, it's because this was how I differentiated on a trig test between the non-calculator and the calculator part. On this particular test, the calculator part was only one sheet and it was in yellow. I don't know. I mean, if I was at school today to be able to print stuff out, I would have been able to do that for this upcoming test. It's not really in the cards. So if you're expecting a multicolored test, I'm sorry to disappoint. It's all going to be on one thing. But here, in this question, you were given two triangles that could exist from this information. 20, 17 were the side lengths, 50 was the angle. So you can see how there are two triangles that can be constructed with that information. And I had us calculate the size of certain angles, depending on the triangle, and the area was another focus. And so I'm just going to actually use that information. We can solve what's given here, but I would actually much rather solve both of the triangles. So if I look at this, I have two triangles A, B, C. If I were to break them down, I'm going to separate this a little bit more. Break them down, so there are the angles. And here are the side lengths. For this is the acute one, and this one over here will be the obtuse one. So side length C is 20 for both. That one's fixed. Angle B is 50 degrees. And side length B is 17. And you can see why this one's ambiguous, because remember what I said, that this side length here, the one that's opposite the angle, it has to fall between the side that's touching the angle, and 17 is in fact less than 20, but it also has to be greater than 20 sine the angle, because that would be the height of the triangle. And so if I, oh, whoops, I was about to type that into my graph. That wouldn't work. If I do 20 sine 50, what do I get? I get 15.32, right? So that tells me right there, because it's between those two boundaries, that this would be an ambiguous case question. And so using that information, I can set up sine law to solve for angle C. So sine C over 20 is equal to sine 50 over 17. Sine C is equal to 20, sine 50 over 17. Angle C, when I use sine law, is something. .64.3. We'll just leave it rounded like that. Now that's the acute angle. So the corresponding obtuse angle I get by doing 180 minus 64.3. And so what I get when I do that is 115.7. I know that's not to three significant figures, but I'm not going to round that to 116. I'm going to leave it as is. So I'm going to fill in that information. I'm just using a different color so it stands out what I've solved for. Once you have two of the angles, you can easily solve for the third because you know they have to add up to 180. So I get 65.7 up here. And on the other one, this one's going to be really tiny. 14.3. Yeah, that seems about right based on how small that angle looks. And so now that I have all three angles, solving for whatever else I need becomes really easy. I mean, you could use cosine law to solve for A. You could use sine law. I'm going to use sine law just to stay consistent. So A over sine of 65.7 is equal to 17 over sine 50. If you're wondering why I'm using 17 and sine 50 instead of 20 and sine 64.3, I always make it a habit when I solve trig problems to go back and keep using the information that was given in the question. Because if I make an error and I keep using my calculated values, my errors are just going to get worse and worse. If I go back and most of the information I'm using is given to me in the question, then I'm actually probably going to stay really close to the correct answer, even if I do make a mistake along the way. Speaking of mistakes, I just copied something down wrong from my calculator. 8.32826, and so on. That I'm going to round to 8.33. So that's this measurement that I just solved for. 8.33 is the length on that side of the triangle. If I do the same thing, but in the obtuse triangle, the angle I'm using is 14.3 instead of 65.7. And what do I get when I do that? 17 sine 14.3 divided by sine of 50. Again, I hope you guys are checking my answers here. 4/8 if I round that one to three significant figures. Oh wait, did I use 7 here? Oh man. Okay, on that first one apparently I did make an error because I used 7 instead of 17. Let's go back and tweak that one. If I change that to 17, that side length is 20. That seems to make more sense. 20.2. Did I have units? Centimeters. There we go. Do we have a decimal threshold, Michael asked, plus or minus 0.5? Yeah, I'm generally pretty forgiving for that. The IB would be too. Usually on their mark schemes, so if the answer was 20.2 was the correct answer, you would see that they have something written for their markers that looks like this, which basically means accept anything within that range of 20.1 up to 20.3. And so that's an ambiguous case question in a nutshell. Now, if you look at the question that I actually assigned here, and I think I'll leave you with that one just as some extra practice, that's how I usually like to phrase them on a test. Having you do the whole thing and calculate all the missing information, it takes forever. I haven't been timing how long we've been on this question, but it takes a little while. And we've been on this for way too much time. So the amount of marks that you'd be getting or potentially losing on an ambiguous case question like this, it's a little steep. And so what I prefer to do in an ambiguous case question is I like to give questions like this one, where I'm having you solve for something very specific. I'm not having you solve for every single thing within the triangle because that takes too long. And then if you make a mistake, you're toast, right? If you make a mistake on those first angles, then everything you're solving for is wrong. It becomes so much harder for me to give you part marks for your work along the way. It's just a mess. And so I like to give you very targeted questions about ambiguous case. The one with the garden, perfect example, right? Because you didn't have to find all the measurements within the triangle. You had to figure out, okay, which one's the bigger of the two triangles, and I'm going to use that one to find the volume of soil. So you ended up only focusing on the acute triangle, even though you knew there was two. This was another example because I gave you the two diagrams. I just said find the obtuse angle in triangle 2 and calculate the area in triangle 1, which is fairly straightforward to do because once you've found, let's consider what you would have had to do there. You'd find this angle, and then you'd find this angle, and that finishes part A. And then to find the area, you would have just had to figure out angle A. And so to find the area, I would do 1/2 AB sine C, 1/2 times 20 times 17 times sine of the angle that's between them, which is 65.7. And that's how I would find the area. So let's take a look at that. 0.5 times 20 times 17 times sine of 65.7. So I get that the area is 154.9 approximately centimeters squared. And that's all there was to that question. Michael asks, will you tell us the triangle is ambiguous? I cannot tell you explicitly because then it's not really ambiguous. So if you're expecting the question to have like big bold text around it that says, hey, this is ambiguous, watch out, that isn't going to happen. I can't really do that because then it's not ambiguous. Ambiguous means that it's unclear or not certain which of the two options. If I tell you, hey, it's this one, then it doesn't become ambiguous anymore. No, but I will say this. It's an ambiguous case question if a diagram's not given and your first thing that you're doing would be using sign law, then there's the potential for it to be an ambiguous case question. I'd strongly recommend looking for key bits of wording in the question. That garden question Donald asked about earlier made it very clear that there wasn't enough information given to make the garden, right? That tells you that there was something ambiguous going on. The question that Hannah asked us about was asking, what answer should she give? I forget who the person was in the question, Katie or something. What answer should she give when she's asked for that missing length? The fact that it's not a certainty, right? I don't normally ask you when I get you to solve a problem, what answer should you give? It's just determine the answer. If it's being asked in such a way where it seems like something's not clear or something's not certain, that's ambiguous case. If you have the information to use sign law but no diagram is given, that's a pretty good sign there's ambiguous case at play. There are all these indicators without me explicitly telling you something. There are ways of knowing that it's an ambiguous case question. And so you just have to make sure that you recognize those when you see them so that you're ready for it when it comes up. We've had a few people pop in and out. We're still at 6. I wonder how many people have been here in total. Oh. Every time I click to one of my other monitors while I'm full screen in OneNote, it immediately pulls away from OneNote. Let's see. That is not the analytics page I thought it was. Normally this thing has a way of telling me how many distinct users there were, but maybe it doesn't tell me until the stream's done. Darn, I guess I'll figure out after. Okay, we have 14 minutes officially on this review stream, so I don't know if anyone else has any other questions. If I was to give you guys a piece of advice, and this is what I would have said in the review class had we been on campus, piece of advice that I'm going to give you is let's list out the skills that I would want to see you demonstrate. So I definitely want to see that you know degrees to radians and vice versa. Please remember that that conversion is not in your formula book. It will not be provided. So you have to know it. And if you don't know it, there's not a whole lot I can do for you there. So I'm going to say here, know the conversion. I'm definitely going to ask you about sector area, and arc length. Just mashing those two together. But realistically, those are very likely to be on the same question. For the most part, it would be really, really difficult for you to do those separately, or honestly, just not terribly interesting to do those separately. So I'm definitely going to include those in some capacity. And then you have to think about the other things, the things that are reviewed from grade 10. You've got SOHCAHTOA, which with Miss Van Huel, you introduced how that connects to area of a triangle. I'm absolutely going to assess you on that stuff. Cosine law, absolutely. Sine law, absolutely. Now, because sine law goes hand in hand with ambiguous case, you have to assume that when that comes up, you're probably going to see those two things together. Cosine law could show up in any context. Area of a triangle, SOHCAHTOA could show up in any context. I would conservatively expect to see each of those ideas once or twice, because you have to assume I'll give you a basic question on it, just solve for these missing values, and then I'll probably try and work in an application question or a thinking question on it where I have you solving for those values. And so I just want to make sure that you're not saying to yourself, oh, cosine law probably will barely be on it. I'm not going to worry, because you're going to get dinged for it twice. It'll be in a word problem, and it'll be in just a regular question, a knowledge question or something. And I don't want that to happen. But if you list these things out, this is all we've done so far. This trig test is usually not one of the harder tests of the year to begin with. But when you consider the fact that we've been hit by snow days, because we're all afraid of winter, apparently, when you take that into account, we've done less content than I would have expected. Normally, binomial expansions would have been on this test if it didn't get bumped, and we will finish it up after this test. And normally we would have done more stuff with trig. We would have started solving some trig equations by now, which also would have been on this test. We would have talked all about the unit circle and how that connects to trigonometry. It would have been a whole thing. We can't do that now, and so it's not on the test, which I think will make things a little bit easier. On this test, you have to know comparatively less, but you'll have to demonstrate it more often. To Michael's question about do I like snow days, I really don't. I'm not a fan of snow days. Anyway, so this is basically a breakdown of the test. You know these 5 things, and you know them well. You can do them confidently without referencing your notes and things like that. Then you should be ready to go. Yeah, I mean, I'm confident that ambiguous case will always be something that's a little bit tricky for people. I promise the questions that I've put on there will not be as intense as my kind of curveball questions that I've given in the past. I was trying to find this one that I've given, but I just can't find the assignment. It was a really loopy question where someone gets like it's 2 people walking a dog, and then they split up from each other. And then one person gets abducted, and so it's like this really elaborate trig question. Abducted by an alien. I should have made that clear. Abducted by an alien. So they get lifted into the air. After you've started with this 2-dimensional triangle on the ground, you then get someone who's levitating away. And it was this really, really interesting question. just because there was so much to it. So many triangles, so much stuff going on. I'm really trying to find it again, which unfortunately means I'm not looking at if people are asking me anything in the chat. Oh, come on, OneNote, get back there. You guys have seen that picture of Tilly and Beatrice now so many times. Oh, it's definitely not that assignment. That's calculus. Let's see. Oh, is this it? Oh, yeah, there it is. I found the question. All right, you want to practice everything all in one giant question? Have I got the question for you? If you can solve this one, you are probably well equipped to handle what's on the test. So this question I gave almost a decade ago now. This is an old gem. Oh, and I've zoomed in a little bit too far. Frank and Zelda are walking their dog Boris along a path. Suddenly, Boris breaks free of his leash and runs into a field at an angle of 34 degrees to the path. Frank is too lazy to chase Boris, so he continues to walk along the path. Zelda, on the other hand, follows directly behind Boris into the field. After running for 35 meters, Zelda catches Boris. Together, the two walk in a straight line back to where Frank has been walking, where the trio meets up again. There's a distance of 21 meters between where Zelda caught Boris to where they meet up with Frank on the path. Suddenly, at the point where Boris, Zelda, and Frank meet up, an alien spaceship appears directly above them at an altitude of 50 meters. The spaceship beams the trio on board. At that moment, how far away are Boris, Frank, and Zelda from the point where Boris ran away? This question is wild. It requires 3 dimensions. It is ambiguous case. It is everything. I love it. It will not be on your test. Notice it says it's worth 8 thinking marks, but this was 8 thinking marks on a take-home assignment that students had like a week and a half or 2 weeks to do. So it was 8 marks because everything was scaled down. It wasn't measured based on how much time you'd have to do it. This one was based on just the question was 8 marks worth of difficulty, whereas others were 4 marks or something. And we gave half marks and stuff then. It was a whole different ballgame. But this is a really interesting question. If you can figure it out and send me an answer, I will be mightily impressed, and you would be well on your way to doing a great job on the test because I'm not giving anything this difficult on there. Anyway, it's a good question to attempt. I would absolutely take a look at it. I promise I will not be making the test with any questions from that assignment, though. So if you are immediately fearful now, don't be. The test will be easier than that. Just looking at what people have been asking. How come Beatrice is so quiet? Tristan, I suspect you meant quiet. Are you wondering why you don't hear Beatrice making noise on the stream? The reason why you can't hear Beatrice is because I'm in the basement of my house and Beatrice is with Mrs. Grant on the 2nd floor. So there's a fair amount of separation between where we are right now. Donald is saying, I think my time has come. The sheer power of this question is far too great. Okay. Yeah, it looks intimidating, but it's not. James asks, so for ambiguous case, I use the second value to see if all the angles add up to 180 or less than 180. No, all 3 angles in a triangle should always add up to 180. It should never be less than. If somehow your 3 angles that you found do add up to less than 180, you've made a mistake somewhere. Right? Interior angle theorem for a triangle, you guys would have talked about that in grade 7, if you were here in Ontario. Grade 8, we talk about it again. It's a big part of grade 9. Interior angle theorem tells us that for any, well, more generally, it tells you the sum of the interior angles of any polygon. But for a triangle, you should know all interior angles sum to 180. All right. I don't know if anybody has any other questions by the counter on the stream, we've been going for 1 minute or 1 minute. Oh my God, I'm so tired. 1 hour, 59 minutes, and oh, hang on, never mind. And 2 hours. That's how long I've been streaming for. I know it's not 3 o'clock yet. I'm not going to cut you guys off, don't worry. In fact, just in the interest of more interactivity for review activities like this, um, if there's anybody who's still here who's willing to help me kind of field test something, there's another way of delivering these review sessions that I'd like to try out. And based on the people who I think are still here, I'm kind of hopeful that at least one of you has Discord. Because Discord apparently now allows screen sharing. And I wanted to see if that would actually work better as a review tool, because then I could actually interact with people live instead of on this 30-second delay. Which means that, as I see these Shaggy memes coming through, I would be able to react to them more in time with how they're being typed. So I don't know. If anybody has Discord, let me know. I don't have it installed yet on this system. But in theory, because I know Discord can do screen sharing, I'm not sure if it can do it in a group call. Like if I could create a DP1 math server for Discord, have people go into it, get in a call. I'm not giving you my personal gaming one, Tristan. That's never going to happen. That would be a huge professional violation. But, if I made a Mr. Grant SJK Discord and then had people sign into it and then practice and just to see if screen sharing would work with multiple users. I'm a little worried that basically if everybody was on a mic, I'm going to get everybody shouting all at once. Do this question, and then it's like, okay, come on, rein it in. But anyway, it's worth a shot. I downloaded the installation thing for it. I wonder if I can install that and get that going right now. Oh, that's interesting. I'm actually just going to type in chat now because that seems to be the quicker way to communicate with you guys. Hmm. All right, so I guess we've worked out a viable strategy going forward. Um, anyway, so I'm going to look into setting up the whole Discord thing. Um, and then, yeah, maybe next time we'll try that. Um, so I'm going to stop the stream now, especially because all of this gets saved to a video that gets uploaded, and this is now just kind of dead air at the end. So I'm going to stop the stream. I'm going to announce that in chat too, just so everyone knows. And